Hi guys.
Share the screen. Hey Richard, how you doing, man?
Good. It's early morning.
That's right.
Early morning here in Kauai.
How is it over there?
Oh, it's nice.
Thanks.
But it's not a good time for me to talk though. So.
Okay. Yeah. Oh, thanks again
Sorry.
for visiting. Really fun to have you here, by the way.
I know. I was going to send you a thank you note. Haven't done it yet, but I had a great time.
A verbal is fine. Yeah.
Okay. Anyway, sorry guys. I'd love to join in, but.
Okay. Yeah. Sorry.
We'll enjoy Kauai. I'm planning on going there.
Richard, before you go, I want to thank you, my friend. You made the right choice.
Oh, good. I'm so glad to hear.
I'll
email you about arranging a one-on-one Skype for us. Okay.
Sure. Make it happen.
Okay. See you guys later.
All right.
Take
Bye.
care.
Bye.
Bye.
Goodbye.
All right. Yes. Let's see if I can share my screen here.
That's a bummer. We're planning on going to Kauai for our honeymoon.
Oh, really?
Yeah, I wanted to see what it's like down there right now.
Welcome to the October 14th edition of The Electric View. I'm Neil Thompson. Today we have Dave, Jim, Heather, Edwin, Robert, James, and Eugene. They are discussing volcanoes and kimberlite pipes, strange geologic features, light in plants, and electrical and subatomic experimentation. Please like and subscribe.
Are there no volcanoes going off at this moment anymore?
I haven't checked. Let's see where we're at here. Just get set.
Well, there's some
like
kind of
a little bit.
erupting all the time. It's the Hawaiian type of eruption where it just slowly creeps out of the earth.
I would agree there with Eugene, but a couple of months ago, they were spelling doom and disaster for everybody because it was erupting.
Yeah, and those were actually not typical for Hawaii, those explosive eruptions.
Right. But, the islands are still there, I think most people still alive and all that. So.
Hi guys, it's James. I'm out here lurking.
Hey James, how you doing?
Doing good.
Nice.
How's it going, James?
Watching it snow.
Right on.
Wow.
Oh my goodness. No snow, not yet.
In Colorado.
Up in Colorado, yeah.
We're supposed to get to 5 degrees Fahrenheit today, so.
Wow.
Where are you in Colorado?
An hour out of Fort Collins.
Oh, okay, yep. A bunch of my friends are in the Springs, and they're posting pictures of how cold it is, and my friend was like, it is curse words cold outside, quote unquote.
Wow.
I was like, wow.
Over here in Salt Lake City, it's pretty brisk. It's a nice fall day. It's clear, crystal clear, but the wind is pretty cold, but it's like that cool autumn day. It's beautiful.
Well, everybody can come visit me. It's beautiful here. It's like 65 degrees and sunny today in Michigan.
Wow.
Yeah, nobody's usually jealous of our weather.
Wow. By losing my rotation, I think so. So they're at Fort Collins, huh? So this is.
Well, you got to go to the northwest about an hour.
Oh, okay.
Into the mountains.
Okay. How long is an hour here?
Right. Because that's an hour in the mountains.
Just about a little bit lower.
Look at that.
See that? See where that? Hold it.
Red Feather Lake.
Zoom in on those little lakes. Zoom in on those little lakes. In the center, right there.
Type in 56 Blue Jay Lane.
There you are.
Oh yeah.
This is Red Feather Lakes.
Blue.
Sorry. Yeah. My keyboard is in a weird position here as usual.
It's there already. It filled it in for you already.
Oh, okay. Thanks. There we go.
Huh.
Is this it?
Oh, right. Spot on, James.
Right there?
Yeah, no, it's right on the roof.
Oh, man. All right. You got these rocks around you here?
Those are my rocks.
Cool.
You can sit on those rocks when the sun rises or sets.
Okay.
And then, smoke a joint there and meditate.
Very nice. Yeah, so there's a meditation spot.
It's Colorado, so,
I'm just saying.
What's up with that? What's up with the house? It looks like it's flattened to the ground there.
It's just a single layer. It's just Google.
Okay. It's the distortion of Google, right?
It's the flat Earth version of Google
right.
Maps.
Okay. All right. This is a pretty cool little outcropping you got there.
It's just above the trees around me, so you pretty much have a 360 view. Mm-hmm. But you can't find these rocks. You go to other piles and try to find these, and they're hidden in the trees.
Okay. But that's part of the property, right? Or did you... Yeah, I'm hauled in there.
Well, so we have some quartz veins nearby, an amethyst mine, and the largest diamond mine, I guess, in northern Colorado, or northern North America.
Wow, okay.
It's industrial, small diamonds.
Uh-huh.
And a lot of Kimberlite pipes. And a lot of just rock piles. Big rock piles all over. A lot of them are just knife-edge type rock piles. Not really that sharp, but they're long and skinny and tall.
Uh-huh.
So what do you guys think about Kimberlite pipes? Are they like a fulgurite from some super discharge or something?
Keep that question. RH, I'm not sure who that is, but can you mute the mic?
What's that?
RH, somebody in the call has a hot mic, if you will.
It's the senior.
Uh-huh.
Well, Mr. Senior, could you just press that microphone button, please, in the Skype call? Now, mind you, then you cannot talk, but if you do, then, I think he found it.
Cool.
And now, if you press it again, you can talk. That'd be nice, too. Hello?
Good. We're good. Can hear everything. Yeah, it's better, right?
I just hope he's not now talking,
Yeah. So we can just go see what this.
So
Richard's
Eugene
situation.
just posted a nice question there. Sorry, Eugene, but it's very disturbing, and we just need to be a little bit professional there, right?
What's that?
What do you mean about it?
What do you mean?
Well,
I didn't. Do we have to look at it?
What?
I'll show you where Richard's at, by the way. So he's right in the. Look at how it's got this moat. It's got a moat around it. See? Down right here. That's where he's staying. So it's a nice little.
In a land called Hanali.
In a land called. That's Puff the Magic Dragon.
Puff the Magic Dragon.
Right. And they've got a moat around. See?
Oh my god.
Yeah. So this is.
Well, I have some strings and sealing wax and other fancy stuff I can.
That's right. That's right.
Yeah. I think it's just the way Google shows you I don't know.
Oh, the outline.
Water.
Yeah. They got it here too. It's a line. They're drawing a line. You can see it. Yeah.
No, I think this is the actual photo of it, whereas the ocean floor is just like a model.
Exactly.
The depth model, basically.
Yeah.
That's what you were talking about that in the email. How it's more like a sonogram mapping.
Yeah, most likely it is actually. Yeah.
But they do the coloration around the shore of the island is just to visually, identify the shore of the island.
Yeah, and I think it's the actual photo of water taken from the satellite. So it's just what you can see from space in this case.
Okay, and then it goes. Then they shift it here, right?
Yeah. Perhaps you can even change this regime so that it would just show you water without the bottom model.
Bottom's pretty interesting, though. That was a topic, right? We're talking about accuracy, Google Maps.
Well, I was complaining a little bit because I would like to have this far-fetched Star Wars thingy where you can, look at your position in space, if you will.
So tell us about Kimberlite pipes. Weren't we going to discuss that?
I was just curious what you guys think, so that's why I asked about it. I mean, there's an idea that they might be basically, these like fulgurites. When lightning strikes, then there's a channel of transformed minerals, right? So there's an idea that if it happens on a larger scale, like what some EU proponents suppose, then maybe it forms fulgurite. The Kimberlite pipes or something.
What you just described is my opinion, what I've expressed my opinion on that field several times already. That is kind of sort of what I think it is, yeah. Personally.
I was thinking that with Jacob Gable's work that the lightning could possibly come from within, like through the telluric currents and burn its way out. And that would demonstrate why we'd see like what they call the cryovolcanoes on
exactly.
Enceladus, right? Be that kind of fashion.
Yeah, I'm with you on that, Robert, too, because the way it seems like the way that the tunneling comes out, and it would have to be someplace where there's a high pressure, high charcoal or carbon to really push down to create that diamond. And then also, like, there's other mineral deposits that are available around Kimberlite pipes that aren't available anywhere else, and you can find them by specific plant species that are attracted to or grow near the mineral availability created by Kimberlite pipes. So they look for that plant, and then they find the Kimberlite, and then they find the diamonds.
Right.
Maybe they are like places where, maybe this is just complete hypothetical, but maybe like the mantle is like a different electric potential or something, and in some places there's a discharge through the crust, maybe, or something like that, and
or in a different past under different circumstances when the Earth was more primordial, if you will, right? That could be too. During the creation process, it could have happened. It could have been relatively recent with another planetary impact. There could be many reasons, but I think the general consensus is that electricity or strike-through pattern or something to that effect is a very good suspect.
Yeah.
Right?
Certainly. For textual.
As far as I can see, they are mostly found on a very old, like very thick places of, in a plate tectonic model. Those places where you find these pipes, they are pretty old and like those shields of crust, right? So it should have probably been some really ancient things that have caused them, maybe.
I would agree with your timetable is difficult here, but I would agree that it doesn't seem to be a very recent event, if you will, right? It seems to be more dated, more antique.
Yeah, that's what I was saying, basically.
Yeah, I would agree. I think, maybe the different mineral composition implying usually there are more metals there, for example, and then we say they come from in the depth of the Earth, right? And they come up. But I would argue that if those were fusion processes going on, creating the heavier elements, then yeah, that would be a nice thing to prove that, if you will.
The thing that strikes me about these is just the conic direction, if there was pressure coming up from below, wouldn't it naturally bulge the other direction and pop, right? Versus, it seems to me this kind of, at least, of course there's confirmation bias always, but it seems to me that this is much more from above than below.
Well, I would say that the lower you go, the more pressure is around you. So it would be natural for, like, if it had like a same internal pressure, so to speak, it would expand upwards because there is lower outside pressure.
Right,
you know?
right.
So maybe this is the case
Yeah,
here.
yeah. I wonder
I can't help but think.
Go ahead.
Oh, go ahead.
Sorry. No,
Oh, I was going to go a little different direction. Go ahead.
Go.
Oh, I was just thinking about the plants that, because there's specific nutrient uptake for per species of plant, and I mean anybody who's ever grown a tomato knows that it's gonna have different nutrient needs than, say, like cabbage or other types of things. So if we could take down the nutrient profile of the specific plants found at the mouths of these things, we might be able to figure out something about the chemical composition of the soil and maybe what attracts or expresses there. Like, did those minerals come from inside? Were they something that was also ejected out, or are they something that might attract a charge to come toward that specific spot?
Or maybe the plants are attracted by some other things, like maybe some remnant magnetization or something like that, or electric field.
Yeah, there's some reason that they want to be there. And I think that, like, plants are often a really good indicator of all kinds of things because they're eating the environment, right? They're eating the color of light, the shade of light, the amount of light, and they're also taking nutrients from the soil in mineral form, but also microbial ecology, like what else is living in that soil with it that encourages this type of community at this spot. And all of those types of informations that we can derive from things like that are really beneficial to understanding why something like that would have occurred in a specific place, or when it happened. When, maybe, how long have these plants been here? And then knowing that would help us understand when maybe it happened.
Somebody mentioned cryovolcanism, and I'm actually kind of curious about. You see, there has been a couple of occasions where in the Russian north, people found strange holes recently, like they weren't there and then they appeared. So some of these pictures of kimberlite pipes actually resemble those, and.
It's funny you mentioned that because I was the one who said that, and I saw someone made a weird post about something called let me see if I got it right, Mel's Hole.
Yeah, I've heard of that. That was a famous Art Bell thing.
It's like, yeah, there's a post on it. It was pretty interesting because if you look at it from the EU eyes, you can really see that there's something going on with that pipe, and that could be like something. There's still some current going. But
no, they had him come. They had him come on, and on the
it spins off. This one actually spins off instead of there's some kind of mutations going on. Ancient, like it's weird.
You throw a rock down into it, and you'd never hear it hit the bottom.
Yeah, but they lowered a sheep down into it like 1,500 feet as far as the cable could go. It came back up dead, but it had like some weird mutated fetus growing in it. And they said it crawled right back down the hole.
Yeah, no, they have all this crazy like lore around that thing. Yeah, it's pretty funny.
But it was like interesting at first, but then they spun off on that stuff. And
he went nuts. I mean, it was great radio, but it just got way out there. Yeah.
Mm-hmm.
Yeah, was that a work of fiction or
there was a guy named Art Bell who used to be, he's really popular on the radio, late night. Coast to Coast AM.
But look it up. There's you can look up. You can actually see the holes.
Yeah. Okay.
And it's not as big as these kimberlite pipes that you're showing right there, because I mean it's a fenced off area. You can walk around it. Yeah, but it goes down there.
Where is this located?
Yeah.
Do you remember in the western United States somewhere?
Okay.
Do you remember there was a couple of images from Mars Reconnaissance Orbiter where they found similar holes on Mars, I think. Like super steep edges and you can't see the bottom, basically. And maybe on the moon, too. I'm not sure. I think there's something like that on the moon also.
Does it do this? What's that? Where's that?
That's too deep for me, you know.
That's pretty wild.
It reminds me of
looks
like
it had a
predators.
vortex in it.
Yeah, you expect like fangs to come out from like all sides. Just like weird, man.
Bottomless pit 65 feet deep. Your Earth. That's striking to me. These. I mean, is that? Where is that? You see these vertical lines. It's pretty striking.
Well, that
Probably
seems like a
around
quarry.
That looks like it was bored, right?
Yeah.
Anyway.
Yeah. They were talking about some like interesting, like if it was like had some current going through it, that would explain why animals wouldn't approach it. They would get all freaked out, and certain plants would grow around it, and then they could actually throw it. They said you don't ever hear anything land if you ever throw it in there. And but there was an interesting, like with the EUIs, you'd say possibly something going on electrical still through that thing, but who knows? They spun off on a weird tangent. I turned it off after that.
Yeah.
Yeah. So basically, what I was saying is that there were occasions recently, in a recent couple of years, when people found like at least I think 3 or 5 such new holes in northern Russia, and people still don't have a theory how they form. So some people suggested something like cryovolcanism, like some sort of internal outgassing, maybe even like natural gas, maybe explodes and forms those like craters. And it's interesting that there are, like in the 60s, I think, or maybe a bit later, there was a theory that such process is actually responsible for the formation of a huge number of lakes in northern Russia. And perhaps also Canada, because, I mean, if you look at northern Canada, there's just lakes all over the place, and most of them are pretty circular, I would say.
You also have the Carolina Bays.
What? Excuse me?
The Carolina Bays, they're all like egg-shaped or oval-shaped. Some of them are lakes, some of them are just geological formations, but they all tend to radially point towards the Great Lakes area. That's always been a weird phenomenon no one can really explain in the geology world.
Yeah, so there's a phenomenon, for example, which is called pingo, where you have this sort of a hill, which is sort of has some internal pressure to it, so it kind of pushes it outwards. I guess because there's a crystallization of water, and since ice is less dense than water, it tends to push the stuff outwards when it crystallizes. So there's an idea that maybe the break of this pingo thing might lead to the formation of a lake, or some crater actually, or something like that.
Pingos are also not too far from myself in the Netherlands. There's a pingo ruin, meaning an old one left over by the Ice Age, if you will. And yeah, what you're talking about now is some explanation I believe they give for an accumulation process of ice underneath the topsoil, and then, create a big bubble, and that melts again, and then you get that formation of that crater, whatever. Pingos, yeah. Due to ice.
It's a pretty interesting one in Belize.
You don't have ice in Belize, right?
No, no, I know. I was just following the image that I saw.
Okay, just checking.
Yeah.
Is that water around it?
Yeah.
Okay, they don't have ice.
Certainly circular.
There goes the ice story.
Sorry about that. I missed the narrative. So.
Hey, just repeating what was taught, right?
Right. This looking up at Canada, there's a formal name for these, right?
I'm not sure, but maybe. I don't know.
Yeah. Let's see if we can get. I saw Buddy calling. Let's see if we can get him on. He knows the name of them, actually.
He's on, isn't he?
No, I don't think so. Maybe. Is he? Maybe. He said he missed the call or something.
He's in the...
Oh, there he is. Okay.
Yeah.
All right.
So, Ito, how did the conference go?
Right. Very well.
Awesome.
Met a lot of people and was in the heart of Italy, as they call it. In some nice big valley. And I was looking at a nice big valley that was drained already during the Roman times to drain it of some nasty swamp. And the Italians say that it's the heart of Italy. And it has a few little humps in the center of that big valley. So I was trying to figure out, through an EU geology perspective what happened there, but couldn't really make it out.
Where was it located?
Typing Greccio. So Greccio. Grecc, yeah. Italy.
Oh, it's of Rome? Province of Rome.
Not sure there. Yeah, seems to be it.
Come back out.
So that's the valley, if you will.
Okay, got it. So
there's
in relation, yeah.
Right. Yeah, Rome is to the southwest there, about 2 hours drive.
Yeah.
So it was very idyllic. They hardly speak English there.
Not too far away from those lakes and chains that Heather was talking about when they lead up to Rome.
There are big circular lakes there, if that's what you're referring to. Yeah, definitely.
I was fascinated always by these three lakes in succession because, they remind what you can see on Mars, the Tharsis Mountains, these three big mountains. So I have this almost obsession with trying to find on Earth places which could correspond to those three mountains on Mars. If there was a discharge between Earth and Mars that formed those mountains, maybe we can find similar shapes on Earth too. But so far, I haven't found it, basically.
Well, you have three of those lakes here, or multiple probably, but three big ones.
Yeah, but they're much closer than the mountains on Mars.
Oh, right.
Kind of had it, but wasn't Rome filled in? Like way long time ago, wasn't Rome filled in? Like just like you're talking about, like drained the swamp and turned it into.
No. Rome is built on the 7 hills, right? Very low hills, but there are 7 higher elevation places within Rome still. Those are the 7 hills. And in between may be filled in and all that. I mean, maybe lots of rubble and dust. I don't know. But it's not like Rome is in a valley, if that's what you're implying there, Heather.
I've just read a lot about how previously I'm sorry, my guy's mowing my lawn. Previously, when I studied art from the Roman area, but before, like pre-Rome, a lot of them talk about when they built Rome that it was a swamp and that they drained it in order to build the city there, and that's part of like the history of it, was that it wasn't that was part of why it was like undesirable land, but it was desirable to them because it was easy to protect by building this structure, the city structure, in the center of an inaccessible space that eventually just grew to be filled in land.
That could definitely happen, because everywhere I go with these ancient Roman ruins, you stumble upon some kind of a story where they built a big aqueduct, or they drained a whole swamp, or they built the biggest monumental whatever buildings, right? or how do you call them? Those arenas, those
Colosseum.
Those stages. Those what's the name again? Those half circles. Amphitheaters. Thank you. And you find those big monumental stuff everywhere. So they were the busy people. They did that kind of stuff everywhere.
Yeah, but don't you think that when they were building the city, they probably didn't have much resources, I mean, in terms of manpower and such, to do any serious kind of work, like draining the whole city or draining this big area?
I don't think it happened in 100-year period. I think it happened over several hundred years while they were also taking slaves and conquering other places, and you know what I mean, like having even before their great empirical expansion, they were still taking over and fighting local.
Here's the thing: you cannot conquer and expand such a small city-state across vastness of Europe and dominate them all, unless you already are far advanced and you have all the modern things going for you. That means, you have your aqueducts, you have your agriculture in order, you have your army in order, you have your resources in order, roads even.
I'm saying it was an evolution. They did build to this point, but it started somewhere. They didn't just start with these things like you guys are saying. Yeah, they had to accumulate the resources, but
well, apparently they had them, because that big valley that I showed, they were draining that in the Roman times, and that was before Caesar even, I believe. So that was BC. Mm-hmm. And they were able to do that back then. It's not me claiming this. I haven't researched it, but
it's 400 BC that they kind of got going with Cincinnatus, I think, was the first one. At least historically, the mainstream 50,000 foot history stuff.
Well, there's a lot of history there.
The big shift was that, the whole into the from a republic into the empire, because they modeled themselves off of the Greeks.
And they were a kingdom before that. That's what I learned too.
Mm-hmm.
Well, they were definitely they were around when the Minoans and did that type of they were evolved from those types of cultures, and they had the abilities to do amazing architectural things as well. So it wasn't singularly focused on the Roman culture. It was a Mediterranean culture at that point where they were all doing amazing things. So if one of them just happened to get the upper hand in knowledge, in understanding, in any of it, you know what I mean, then that might be attractive. So not only are they maybe they're just not necessarily taking over other places, but people are willfully joining them, willingly, hey, I'm going to move to Rome because they got it going on there. I mean,
yeah, basically Rome was one of the many Hellenistic states, so to speak, which you find many such places, even in Africa, in Spain, in even the Middle East, like Lebanon or Jordan or Israel.
Caesarea, I was reading about that last night. It's right on the coast of
in southern France and so on. There were lots of these colonies of Greeks and of other peoples, but they pretty much shared this Hellenistic culture.
Mm-hmm.
But somehow Rome just dominated the whole scene afterwards, with its military and administrative and other kinds of resources.
It's pretty interesting, that polarity between Athens and Sparta, because there was certainly a philosophical difference between the two, and there was a mixture, I think, that kind of happened, with the culture in the Roman Empire, etc. But they leaned more towards Spartan philosophy, and it was from my reading and stuff, they kind of look down on the the more ethereal Athenian, philosophical and art ideas. And I think it's an interesting polarity from a philosophy standpoint.
Yeah, I see where you're going with this, but I personally believe that, and I'm not the only one who believes that this myth of Spartans as like super good warriors and so on, it's exactly a myth. It's basically a propagandist, I don't know, idea, because what Sparta was always famous for was their women, basically. If you remember, the Helen of Troy is from Sparta and so on. But this myth about Spartans being like super good warriors, it only came to being much later, after this 300 Spartans thing at Thermopylae,
right?
Where they actually wanted to abandon the place and fight elsewhere, from one account, at least, and from the other account, it seems like the Leonidas, the king of Sparta, he actually kind of planned this whole event to be just like a propagandist,
really,
thing. Yeah, he actually, like, there were accounts. I'm not sure who the historian is, but it's pretty easy to find, where he says that many people approached Leonidas and said, "Why are you only taking, like 300 men? You're gonna die. There's an endless like army of Persians going on to our land." But he kind of, mysteriously said that, of course, we wouldn't stop them, like, and we wouldn't win the war, but 300 men is enough for what I need, which means like he just wanted to die as a hero.
It was, right. So right. But I mean, that's a long way to go for just some propaganda.
But I think it fits the whole.
It worked, right?
yeah, exactly. And I mean, if Spartans were such good warriors as they are seen today in our culture, then why didn't they have any success in Olympic Games, for example?
But there was I mean, there was battles between Athens and Sparta, though, from my memory back.
Yeah, well, they were also trying to resist domination, right? There were many, as Eugene put out, many Hellenistic states,
right?
And Athens was becoming a dominant one, as far as I understand. And Sparta was trying to stay independent,
Yeah, I mean, this was
you fall into.
It was super diversity, because they had the city states, and each one had its own, their own culture, their own, kind of signature culture, and because of this, they would fight each other all.
We still do this often. Today. We call it football. Nothing changed.
Right. Yeah, bread and circuses. Yeah.
I think if we haven't had a hydrogen bomb, we would have even like regular wars, even between the current states.
Yeah,
I mean, it's just impossible to wage wars anymore, because we would just die. Everyone would just die.
Well, that big, massive, gargantuan threat, right? Of that thing with the superpower,
right? Yeah. And in this regard, I would say.
Let me ask. Let me pose a question to Eugene. Then, Eugene, you pose excellent questions. Let me treat you one back. What are your feelings or your thoughts about the topic LENR, low energy nuclear reactions, or condensed matter nuclear science, meaning cold fusion? Take your pick. What are your thoughts there?
Well, I think it is not impossible. That's what I would say. But I'm not sure. I haven't seen any real evidence for that. But maybe it's just
real evidence.
Yeah. So, well, I don't know, any kind of working device, I guess, or working setup that would produce this kind of things. But I mean, to be honest, I haven't researched it thoroughly, so I can't say that there are no such devices. Maybe there are.
Well, regardless of actual devices that are on an industrial operating market wise running scale, but if there would be an experiment that would show transmutations to be real, for example, due to electricity or in a plasma environment or whatever, would you accept at least the phenomenon being real without, a real device yet, working device?
Yeah, certainly. And for example, I was really fascinated by sapphire data. You've heard about that they supposedly they got atomic mass of 3, which means out of just like regular hydrogen. So if I'm not mistaken, but I think it is the case.
Yeah, they talk about number 3, yes, for sure.
Yeah, so I was discussing it with Michael Claridge at the recent OTF conference, Ben Davidson's Observing the Frontier. So I actually said to him that we've had a panel with him together, me and him, like Q&A session of sorts. So basically, I said to him that maybe it is possible, even explainable through like regular quantum mechanical principles. In particular, for example, a couple of my colleagues work on the purely theoretical work of modeling the probability of tunneling, quantum mechanical tunneling, in the case of perturbed potentials. So if you have a periodic potential like the one that you have, for example, in crystal lattice or something, then there are like energetic barriers, for example, for electrons, represented by these periodic cells of positive and negative potential.
Like layers, if you will.
Yeah. And so basically, in a nutshell, the work of these colleagues of mine have shown that it is possible to perturb the potential in such a way that the probability of tunneling becomes much higher, basically. And what it means, for example, in case of fusion, I believe, is that, well, to achieve fusion, you need to combine 2 protons, for basically to negate their how do you call it? Their electrostatic repulsion, right? Because
the Coulomb force.
So they're both positively charged, so they repulse just through electrostatics. But you need to somehow overcome this repulsion. So, and this might be achieved with quantum tunneling. And again, if we know that we can perturb the electric potential in such a way that tunneling would be enhanced, the probability would be higher than it kind of should be, then it is possible to achieve fusion even with kind of lower energetic requirements than it is what follows from like regular calculation based on just taking the value of the force that you need. So I think it is possible in this case, and maybe this is actually what they observed, but it's very uncertain at this point yet what they actually observed in Sapphire experiment. And what I also thought about was that, well, I have an analogy, but maybe it will be too long to explain with the analogy. I'll just explain it without it. So basically, maybe even though they have electric fields which are not very strong, maybe I actually don't know what kind of fields they have. Maybe like kilovolts per meter or something, 100 kilovolts per meter. So it's not a very strong field. So the electrons that they have in such a setup wouldn't have much energy. It would be not enough to for the fusion to occur, you know. But okay, this is really complicated without the analogy. But anyway, so maybe, okay, one electron wouldn't have enough energy to kind of help proton to achieve fusion, or protons themselves wouldn't have enough energy. But maybe many protons combined would have enough energy for at least one proton to achieve fusion. So maybe there's a way of like sharing this energy between protons, you know, right. so that many protons might contribute to at least one of them and help it to counteract this Coulomb barrier and achieve fusion in the end. So this is sort of another, I guess, explanation for what they're observing. But I mean, not the actual explanation, but it's an idea that might be true in this case. Or it might not be true.
No, I love what you just said there. I mean, I've been referring to the conference that I've just been in Italy. You would have done great there. I mean, there were many people talking along these lines and these lines of thinking there, Eugene. So you're talking in the letters, you're talking resonance, you're talking cavities there, you're talking electricity there. There were all kinds of theories that kind of what you were alluding to. And those passed the agenda, if you will. So you're definitely open-minded there. Can I summarize it that way?
Yeah, definitely.
Okay.
Yeah, I like to explore alternative theories. That's what I like to do.
Yeah, same here. You know, not the already beaten down paths, I think is the term.
And I just want to mention it because maybe you would be interested. Again, this analogy that I had, why I came to such an idea, it comes from the photoelectric effect. Maybe you know that during the early years when people studied photoelectric effect, which is basically the effect is that you shine UV light, ultraviolet, or maybe X-ray, maybe gamma rays, onto the metal or some other element, and this light ionizes the surface atoms of the metal and kicks the electrons out from it, right? So it's a sort of a way of generating electrons from photons, so to speak. You just send your photons onto the metal surface, and they kick out electrons from the metal. And so there was it was known that there is a certain limit of frequency of photon below which, if the frequency is below this limit, you cannot kick the electron out. So the photon doesn't have enough energy to basically release at least one electron. Right, and it actually was one of the reasons why quantum mechanics came to be. The Einstein's work on the using the hypothesis of Max Planck for explaining the photoelectric effect by considering light as being streams of those photons, not as a wave, and so on. But anyway, but this red. It's called, I believe, the red limit of photoelectric effect or something like that. And red because it's usually in red or infrared, so it's like a long wave radiation. So if you go below this limit in terms of frequency, you cannot produce electrons anymore. And if you're above, you're good to go. So, but this is only true in the case of low intensities of light. So if you have like regular sources that were available at that time, like in the early 1900s, then indeed you would have this limit. But if you have a very strong sources of light, like laser beams of really high intensity, then what is possible to happen is that several photons might interact with only one atom, just because there's so many of those photons, you know, because you have light of high intensity means a lot of photons essentially. So even if it has a frequency of lower than this limit, so one photon cannot kick one electron out, still you can have two photons kicking the electron out, because combined they have more energy than what is necessary.
This is very interesting, Eugene, but let me ask you a question there, because otherwise I'm afraid I'm not understanding anymore. But you said the quantity, so the intensity of the source suddenly was playing a part. But to my understanding, and correct me if I'm wrong here because it's far away, but this photoelectric effect that it is quantized, that's what made Einstein basically so famous, right? That was to show that the intensity, so that the intensity was not of any effect. So it does upset that work, if you will. Is that what I'm hearing you say? That the intensity, the saturation level can violate that principle, if you will.
Well, in a way, yes. So he was dealing with, again, the sources that were available of low intensity light. Well, relatively low, relative to the present day lasers, essentially. So yeah. And probably if they knew about this effect, the multi-photon absorption, when one atom takes not one photon but several of them, then it would actually complicate the development of the quantum mechanics and stuff. But those are kind of a higher order effects, which are again visible only when you have a very tightly packed light beam, packed with energy, so to speak.
Right. Interesting.
Yeah.
Well, that's maybe one of the things that's nice to mention, that from the conference that there are quite a few people in mainstream, including people that use quantum mechanics definitely as their source, as their model, right, as their thinking. That for instance, what I'm saying about another way of looking at a neutron, right? We talked about that. That idea is not so far-fetched, and there are quite a few people that are playing with that notion, with the idea of seeing things more or less in the older model, Rutherford, I believe it was, like a proton-electron model. There's quite a few people that think along those lines, so that's falls in line here, I think.
And what do you think about neutrinos? Do they exist?
I have
in your opinion.
Yeah, I agree. This is my opinion. First of all, I really do not know. I have no readily answer there. I do have an answer, but not readily. So, to just repeat very shortly there, a anti-neutrino came into being because of the spin. Now, what do we mean by that? A neutron decays into a proton and an electron, and they all three have a spin of a half, plus half. Now that means plus a half equals a half plus a half. That cannot be. You miss minus a half on the right side of the equation. So they put minus a half there, called that the anti-neutrino. Now, my answer is, put the anti-neutrino on the left side of the equation, so you get a neutrino, not an anti-neutrino, but a neutrino because it became positive. Plus a neutron becomes a proton and an electron. So what I think, truthfully, Eugene, what I think is that the neutrino, whatever that may be, whatever we call it, whatever it is some kind of initiation energy or the amount of energy that needs to be stolen from its environment in order for the decay of the neutron to take place into a proton and an electron pair. That's how I see it. So I see it more or less as an initiation energy / that amount of energy that is needed to make that happen. It needs to take it from its environment in some form to make the decay happen. Either one of those. Take your pick.
Yeah, well, it's actually the basis of the idea of neutrino in the first place. Not only they had problems with spin, but there was also a problem with energy conservation.
Yeah, and mass defect. Yeah.
Yeah, there's a certain energy missing after the decay if you don't consider neutrino. So there was actually a pretty interesting line of thought which was pursued by Niels Bohr, for some time, and some of his colleagues also, that the conservation laws weren't actually applicable, at least in this case. So, but they haven't got far with this line of reasoning, and eventually the people who argued that the conservation of energy actually holds even in this case, but it's just the invisible neutrino that's taking the missing energy. So this idea prevailed eventually. But who knows? Maybe if we pursued the line of Bohr, maybe we've had some other theories and some other possibilities arise.
I constantly see when I look at this thing, like the rise of energy depending on frequency, and then the ideas of angular momentum come into play, at least in my mind. As far as
what do you mean?
And like if you think of the frequency as a obviously 2 dimensions, it's a sine wave, but you can think of it as a spiral in 3 dimensions, right? So if you think of it of passage of time in as the frequency goes up, the angular momentum of whatever's moving or changing goes up, and angular momentum as potential.
That's an interesting idea. Yeah. And you know that the photons can have like a different polarization, so to speak.
Mm-hmm.
So for example, the beam of light can be circularly polarized, which
right.
means that basically the spin of the photon just spins, so to speak. So it kind of turns like in screw-like motion,
right,
in space.
What's the pole? I was just going through some stuff that ran across, but the magnetic effect on polarization. Are you familiar with some of the details of that? I mean, I'm foggy on it, so it's like it happens, right?
I actually did my thesis at my university in optics, so I know
cool.
a little bit
Awesome.
about it. Yeah. So basically, there are certain effects where the magnetic field can actually influence the polarization of light directly. For example, the Faraday rotation, which you've most likely heard about, which is exactly the influence of magnetic field on the polarization of light. So it kind of, again, it's sort of a more higher order effect, so they are not that strong, at least most of the time. But they are there, and some I think even some devices utilize this. Faraday rotation is probably the more.
Okay.
Well, yeah. The pictures pretty much show you that. Yeah.
Right. Okay.
And then there are also other effects associated with electric field. For example, there is a so-called electrogyration, where you have the changing of the polarization of light through electric field. Well, not going too much into technical details, I'll just say that those effects can actually influence the refractive index of matter. So, for example, there's Kerr effect, which changes the refractive index of the stuff, the matter that the light is traversing through, because of electric field. And there are, I definitely know that there are practical applications of that. They are called Kerr cells, KERR cells. Where you have a piece of crystal with electric field applied to it, and it performs some manipulation with light, essentially.
That's so. I didn't want to like interrupt you because it's like so interesting, but it's a question that's been popping up, and then for me, because like right now as we're talking about this, I'm looking at a crystal, right, with the sunlight shining through it, because I want to see what you're talking about, and it's an emerald calcite, which is like a light green crystal, okay, with a lot of lattice going in, and every place that the lattice structure intersects within the inside of the crystal, there is a refraction effect happening, and little rainbows are popping out. And it creates different spaces within those little lattice works, and how the light is interacting with itself within the structure of the crystal. And when you were talking about how like there's low energy, that the red limit, that below that red limit, when you hit infrared, it's no longer enough energy to change the electron. So but I was thinking about this, like at the refractive levels, the shape that's happening inside of there, and how each cross section is taking apart the sunlight as it's going through it, and it's turning it into a prism, it's separating it all, and then each angle is reflecting those separations and refracting their own, and it becomes this. It's like, where does the sunlight start? How broken down is it within these lattice structures, and how do those refracted frequencies affect, like if the sunlight is coming down through it because it's refracted, does that mean that the sunlight is lessened in intensity because it's been broken down into its spectrum, or does that mean that it's magnified?
Both things can happen. So refraction, polarization, those things can happen. But if you're talking for material that is more or less transparent, which is most of the materials, then I would argue that usually it's the absorption that takes away certain colors, that leaves certain colors, and that's what we see. So the green in the leaves, we see the green because the red and the blue are filtered out by the green leaf stuff. What's the term again? Chlorophyll, right. Chlorophyll. So it takes away the red and the blue spectra, leaves the center, which is the green, hence the leaves are green, right? So that is what is not absorbed, if you will. But it's not the entire truth in colors. There's a more mixture field there.
And it's actually very interesting that the green color is actually the green photons they represent the maximum of solar radiation density. So the sun is most brighter in green, basically.
Right.
It's about, I'm not sure, maybe 3 electron volts or something like that.
Yeah, it is sort of in the center of the spectrum somehow.
Yeah, green, the sun is actually kind of more green than red or blue or something.
Yeah. I mean, it's interesting that our eyes are right on that, that band, that little 1 octave band.
Yeah, but if you consider like the evolutionary ideas, it's not so surprising. I mean, we tend to see the kinds of electromagnetic waves which are possible to see in our lower atmosphere where we live, and those are exactly this visual band from like 400 to say 700 nanometers.
Right.
But
the full spectrum, like if you take the sun and you do a wide band analysis of like what's coming off of it, what's the power density according to, is it focused on where our eye is, or is that where the majority of it is, or is it also outside of it?
Yeah, exactly. As I've said, the green photons are the most prominent. I mean, they carry the most energy from the sun. Mm-hmm. But you can Google the spectrum of the sun and you will see that. And the maximum, the peak of this curve would be in green. Not exactly sure, but maybe like 500 nanometers or something.
It's like 55K. Between 55 and 65K.
Yeah, they haven't even have the well, I'm not so sure about this yellow.
Yeah.
I think it should be green actually. Yeah. But again, it's just curious how plants who live off the energy of the sun, they actually don't consume the green. They kind of miss the maximum of the radiation. But it kind of
Is this really it though? I mean, like,
yes, more or less.
Is it possible that that this is actually filtered?
Yeah, the atmosphere, it either absorbs or scatters most of the other wavelengths. And not only the atmosphere itself, I mean the gases, but also the water vapor.
Uh-huh.
It's also really important in the infrared area, and maybe EUV also.
Have they done this like with the satellites? I mean, I'm sure they have, but sampled outside of the atmosphere.
Yeah. There were definitely many such studies, and you can even find pictures of that where you would clearly see, I mean, explicitly see what parts of spectrum are like absorbed by the water vapor, what are absorbed by the atmosphere. You should just search the Google pictures.
Yeah. Like atmospheric absorption of sunlight.
Well, this one, the third picture that you can see here, for example. Yeah, this one. Although it's kind of small, I've seen bigger pictures of the same sort.
Yeah. Okay, I got it. Back to the solar radiation. I can get my.
And it's actually curious that in space the sun is actually white, whereas on Earth we see it like more yellow, sort of. So it goes to show that the blue part of the solar spectrum is highly scattered by the atmosphere. So if you take white sun, but you take the blue out of it and kind of sprinkle it all over the sky, so the sky would be blue. Then what the remains of the white is yellow. Because blue and yellow are complementary colors, so they add up to make white.
Right.
Well, not quite. I mean, from this is from like a more of a art perspective and plant. Like I've done a lot with color and light and how they relate and how plants eat them and how the spectrums are broken down and why they're broken down that way. And so when you talk about complementary colors in a color wheel, like art perspective, it's very different than when you talk about the light spectrum itself and like the actual waves that are interacting with.
Well, they could be additive. They could be additive.
Well, in this particular case, we would be talking about how the humans perceive them, right?
Right. Well.
So looking at a blue object for a while, and then looking besides it would give you a yellow haze, or in this case, an orange. Reverse.
But the reason that I'm bringing this up is because, like, to talk about the yellow, like yellow is kind of in the visual spectrum, kind of an impure color or like a leftover color, like you're talking about, but it kind of seeps into green or red. Right, so orange. It could be orange, it could be green. It's very like limited.
Well, there's your sunset, I would argue.
Right, but look how little that yellow band is. See how little that yellow band is, because it's either going to be green or it's going to be orange. There's a very limited amount of space where it actually gets to be pure yellow, if at all.
Right.
Even in this, it's just showing it, but it is minute. It is either green or it's orange. So the way that it's taken apart, just to clarify it for people who are listening, because I know at first I was like, wait, what? You know what I mean? Because my art background and color wheel is kind of, that training is kind of different than when you look at like visual spectrum, because Roy G. Biv is different than a color wheel. Where you have primary colors and secondary and tertiary and things like that. The way that we break down colors in a process. to create layers of colors and use it to paint. That's kind of a different thing when we break it down in how plants digest it, how we see it, because animals see things differently. I mean, obviously they're like dogs don't see in color because they don't have those specific rods or cones to see.
Mm-hmm.
I don't know. That's what I was just
trying
to express, that that the visual spectrum and the fact that plants and things like that eat infrared. They also eat and different kinds of animals see those to understand what other, like when they show what plants look like in infrared or the other types of light that they're emitting, you get this really ethereal black light. Like you get like a totally different critter than the way that we as humans visualize things. And that's the light, the difference in the light wave perspective. I don't know. Really
no, it's good.
Yeah, well, definitely different beings would perceive the world differently. That's kind of obvious. So maybe they would see an infrared or something where we don't see. So we have no idea how, let's say, a dog perceives the world. I mean, how it, it's a very old problem in philosophy, like the problem of qualia. How would you explain to a person who haven't seen red color in his life what is red color? How it looks like. So you cannot.
Right.
And there's even a bigger question: whether even people who can't see red color
see it the same way, right?
Yeah, exactly.
Yeah, right. Right. And then I get into, I mean, just avenues of thought. We're going to measure and get like really high detail on things that we can perceive. I see the drop off in the power of level of the spectrum, but is this also just a window of, well, since we can't perceive it, it's not there and we're not looking?
I actually also had an intuition, I guess, an idea concerning this, purple dawn kind of thing. That, if Earth ever was a satellite of Saturn or something, many people like Eduardo Cardona and Walt Thornhill speak about this purple glow of Saturn or whatever. So why do we even see purple? Why do we consider it such an important color? Because there are no purple photons. Purple is not a wavelength. It's a combination of blue and red, essentially, right?
Well, what about ultraviolet? I mean, this is where I think, because if you think of octaves and you start thinking of music, it's like, the notes repeat, right? The quality of the notes repeat as you go up, depending on if you want to base it on a certain tonic, but it's the same for, in our Western scale, all 12, right? But as you go the next octave, the quality of that note is repeated an octave higher, right? So if you look at ultraviolet, it's pointing back into red, which is an octave below.
Yeah, well, basically my point was that maybe we actually put such importance to purple, which is essentially a mixture of two types of photons, the red and blue. Essentially, purple means the absence of red, because if you kind of see, if you remove the I'm sorry, I said red. I meant the absence of green.
Green,
sorry.
Right.
So if you take the whole spectrum but remove the green part from it, you would see purple. And so purple is like the absence of green photons. So maybe actually
is that how it's measured? Is it measured that way?
Well,
I mean, so just to bounce it around a little bit, the ultraviolet, right, up here, or down here, as far as wavelength, but that wouldn't you consider that purple?
No, I don't think so. It's more like a deep blue or something, well, like a navy blue sort of.
That would be like the indigo.
But that's got a
deep blue with like a greenness to it.
Okay.
But violet is on the visual spectrum, but it's like it comes after that deep blue. And I don't think that the visual spectrum goes from ultraviolet back into infrared, because then because it is along the electromagnetic wavelength, it continues to go, but it turns into different kinds of waves. That's why I've asked before if wave degradation, like the red shift, blue shift, could, it's just like the wave slowing down or speeding up, if it's just a change in the frequency of the same initial wave. But purple itself is blue and red mixed together when you're mixing paint together, or you're trying to like layer, say, like transparencies on top of each other to create this color. But violet isn't purple, and it is a color on the spectrum. And so I always thought, I guess internally or intuitively or however, that the reason that people put purple and violet as such a like royal color is because it's the closest thing to ultraviolet. It's the closest thing to pure white light that they could envision. Like if you are an elevated soul if you wear purple, because you are almost there.
They certainly use it. I mean, and subtle, subliminally, they use it quite a bit.
I'm leaning with
maybe not so subliminally.
I like all the explanations, but I particularly like Eugene's, because this color green is definitely associated with life, green leaf stuff, right?
Yeah.
And the purple is always associated with spirituality, enlightenment, becoming higher spiritual being, etc. Nobility. That's what it's associated with. So that's the color, indeed, as Eugene points out, if you take away the green. So you become loose of nature, if you will, your enlightenment. So that resonates with me somehow.
There's also the blood one, where it's like oxygen rich here and then oxygen depleted here. Yeah. Just to throw another log in the fire.
Well, what does that do to the color then? I'm not sure.
When blood is depleted of oxygen, it turns bluish.
Right. Well, it loses the redness, right?
Right. Uh-huh.
So yeah, that's not a good thing, actually.
Oh. Yeah.
I like the idea, but at the same time, I'm like, but all of our plant friends, like they're green to protect themselves from the most intense of the light rays, right?
Because they're blocking it. Yeah, they're blocking. That's what.
Yeah.
Yeah. Mm-hmm.
But the green,
because they're absorbing. Here's an interesting little diagram here, right? So
from a biochemistry point of view, what is being taught is that the plants have difficulty using the green wavelength. I'm not sure about the explanation back then, but I do remember that the red and the bluish spectral lines, that they can more readily absorb them. Now that is of course due to the underlying biochemistry for some reason in the physics, but yeah, that's what's being taught. So the green is not usable. Maybe it's because it's too energetic. I don't know. Maybe because it's too intense. Could be.
Yeah, but there are also plants which are not green, so they probably take some of it inside of them.
Yeah. Well, that's not because they don't have the chlorophyll, I think.
Generally, a lot of times when plants are a different color, like say a red leaf plant, it's because of the alkalinity of the soil.
Where's the train?
I know, I was I was so loud.
Heather has a train that like it indicates important points.
Yeah, this means something. Message. The train concurs.
Yeah, very
little
interesting.
Daily ritual there.
It's like every 20 minutes. There's a train.
Very cool. Very cool.
But the thing too, though, about plants and the spectrum that they are absorbing at that particular time, the light that comes in, like the angle of the light that comes in through the atmosphere, changes the temperature of the light, the color that's coming through. So it tells the plant what time of year it is and what time it is to do what. So when it goes down to about 3000 K, it's nice and warm in the fall, and they're like, okay, we need to shut down for winter. It's time to flower. It's time to fruit.
Right.
The color of light is an indicator to the plant for hormonal and metabolic function. So when plants start behaving in funny ways, it's an indicator that there could be. I mean, okay, so like they're just turning color in the middle of July. That in large spanses could be because the color of the light that they're receiving is different than what they're normally used to at that particular time. If you've ruled out everything else, if you've ruled out, like water and disease and nutrient deficiency, if all those things are ruled out and this thing's still changing color, it's the light.
To your knowledge, Heather, have there been experiments trying to mimic that? So you changing the frequency and keeping the length of the day, mimicking that similar, or something, or make it think it's springtime while you give it the rays of the fall?
Oh yeah, people do it all the time. There's a whole industry is based on.
Okay.
Because when you want something like you want a strawberry and it's December, you could get a hydroponic indoor grown strawberry, and that's how they told the strawberry what time of year it was, by playing with the light.
But do they also use the frequency as you suggested instead of just duration?
Yeah, because bulbs that you buy for the indoor growing, or even outdoor growing, or like whatever, if you want to, like my orchid needs a specific type of fluorescent light sometimes in the winter. So I put one in my kitchen sink and I just put her over there, because that color that's coming through in the bulb that I bought the specific color bulb that it needs. So I'm catering to the need of my orchid by buying that bulb.
I agree there, because I know that when people were telling me about growing pot indoors, you got to grow like high pressure sodium light bulbs and at a certain time of the year because they give off a certain frequency of light. I can't remember. I think it's the red spectrum. And earlier in the year, you need to give them the blue light, so their vegetative growth is better as opposed to fruit growing. So yeah, they do manipulate the light cycle and the time of the light too. They control that a lot.
Actually, if you do a long blue cycle for 18 or more hours a day, it keeps them in the vegetative state. And as soon as you drop them to a 12-hour day in red, they start to bloom. And you can hold them in a vegetative state as long as you want until you drop the time down to 12 hours.
And they go to flower and then they die, yeah.
And then if you try to go back and try to put them back on an 18-hour, they get totally confused.
I can see that, yeah.
It's a science.
So did you ever notice?
Definitely. All of a sudden you dive into. I mean, this is an interesting thing because here's an example of you dive down into detail when it's of interest, But there's confirmation in it, So anyway, there's a certain theme there. I'm probably going off in left field, but anyway.
Well, a theme that you can dive into is you see two types of chlorophyll there, A and B. And that has to do with temperature. That is related to temperature. And if I say something wrong here, I'm sure Heather will jump in. But either one of those, I'm not sure which one, gives the plants the ability to grow at temperatures below 15 degrees Celsius already. So above freezing, they more or less start growing. Those are your early type of plants and the plants that are more northerly. And then you have a lot of more tropical-based plants, if you will, and many vegetables in your garden have that too. They cannot stand freezing, for example. And they only grow from 15 degrees and upwards. And they have a certain optimum at, 25 or something. And those two chlorophyll types are used in plants as well.
It's also interesting. Sorry.
Yeah, go.
I was just going to mention the influence of light on animal and human behavior, because it is known that, for example, Well, I remember one really curious experiment that has been done in Japan, for example, where they've had a street where there were lots of suicides somehow, and they've changed the street lights to blue ones. So the street was, in the night, it was illuminated with blue light, and there were basically the suicides stopped there.
Wow.
You know? So somehow blue light actually reduces the level of, I don't know, violence or something like that, or self-violence. But actually I think the conclusion that was from this experiment is actually that blue light is just uncomfortable for people, you know. So they just tend to avoid this whole area, not only in terms of suicides, but they just don't like it there, you know.
I do hear that a lot more. That the blue light, especially in the time in the evening hours, for me it's now evening hours, you know, monitors and stuff. And the blue light seems to be harmful for us. I do keep hearing that. Yeah.
Go to that one that says design goals. See that one that says design goals? Check that one out.
I was just half an hour ago working on a Redshift program that adjusts my screen's hue according to the time of day.
Wow,
yeah,
that's a cool
I use that too.
Daytime it's blue.
Really?
Okay.
Flux, yeah. Probably
Flux,
you're talking about Flux. Yeah, it's a great program. Yeah, I love it. Yeah.
Do you find that it enhances your mood?
It definitely
no, it's
that's sharp.
It just kind of calms you down in the evening and night. So you just don't feel as stressed, and you have basically much better sleep after you shut down your computer.
Wow, interesting.
I find it much less painful to my eyes, especially in the dark when the contrast is higher. So the brightness is often too much still, and it turns it reddish. You have to get used to it, and you can adjust it to your liking, but you have to get used to it at first. But personally, yeah, I do the same thing. I install it every time on a new PC now.
It's a great idea. I mean, this is a massive area of study. I think there's been a lot of study on it, but it's been a little bit. But it should be in the open. They're talking a lot about, because we're so just immersed in these screens. The health issues are really an important thing to consider, and our psychological impact, etc.
The thing is, though, is that like they already know this. Like if you go into interior design and you start looking at like light, understanding like light and placement and what types of lighting are cohesive or conducive to what, because they understand what kind of light is going to sell you what. Mm-hmm. They understand what kind of light's going to calm you down, what kind of light is going to entice you and aggravate you.
Right.
Whatever they want to do. If you look at advertising, they're going to have those kinds of answers for you because
definitely.
Utilizing that every day.
Right.
It's
a great area of I've looked at it and looked for things regarding that, but it'd be a nice one to get just as far as much more wide public awareness of. Because what happens in commercials, et cetera, all the subtle things that they can do with color, et cetera.
Well, not just that, or when you enter into a space, like when you enter into a store, when you enter into a grocery store, when you go into an office, an insurance agency, wherever you are, the interior designer is going to understand how to set up the lighting in order to make you the most comfortable to do what they're asking you to do.
Right. I mean, just wall paint, the subtle differences in whites, for walls, between. I'm not a painter at all, but I've seen just the massive color charts that you go in a paint store, etc. But that difference between like slightly into the reds or slightly into the blues or greens, it's massive effect on how the room feels. Right?
Yeah, and returning to what I was talking about with Saturn hypothesis and stuff. Mm-hmm. So I'm just curious again. Why do we regard that it's purple, which is essentially a combination of red and blue? And I believe that Ido had a great comment on that, that if we regard the green as the color of life, that the purple is the color of sort of a transcendence or something, like being over your mortal shell or something. And it just fits, I believe it fits perfectly with the Saturn narrative where, the sky was purple at some point, perhaps, if it is correct. And, and I believe that it can be tied somehow with the fact that the sun is actually mostly bright in green. So green is the purple is sort of the absence of green. When we see a combination of two wavelengths, like, just any two wavelengths, then our perception is to, when we mix the two, we perceive the result color as the one with the frequency between the two. Kind of you sum the frequencies and divide it by two, and that's what you see. But if you combine red and blue, you get the combination gives you green, right? But you also have cells that can detect green light, and if they don't see it, then you see purple. So again, the purple is the absence of green. So you see kind of red and blue, but you don't see green, and you see purple as the result of that. So
when you're saying the average,
excuse me,
when you combine the two, you're saying combine the two.
Yeah, the average.
Yeah,
the average
right.
Yeah,
right.
Because when you're using the the white light, they use blue, red, and green to use it, and when you filter out the green, all you have is left is the blue and the red.
Mm-hmm.
Right?
Yeah, and so I'm just curious how our basically well-being, how our perceptions would change when we would go into areas with other electromagnetic spectra, so to speak. So even in space, we already see kind of radically different picture of the outside environment. The sun is white; it's no longer like yellow or red, and there's no blue sky above us, and so on. There's just like a black sky everywhere else.
Right, right.
It's really curious how people would feel if they would have to be in such an environment for a whole lifetime, for example. I mean, some people have been on the space station for a year, or plus minus, maybe a couple of months. But what if you spend your whole life in space? How would your perceptions change? Or if you spend a whole life on Mars or Moon or other bodies, that's super interesting how we would adapt to such environments. I mean, obviously we can simulate what we have on Earth, and maybe we would do that just to cope with our innate sort of abilities, innate perceptions. So maybe people would use like virtual reality just to, feel Earth around them wherever they are, or something like that. Mm-hmm. It's a really interesting topic to think about. But maybe, maybe there would be some kind of more radical people who would say that, we don't need this, artificial recreation of Earth's conditions. We want to evolve into a new spacefaring kind of species. So we would just see what kind of changes would these environments impose on us as we are, as they are.
Mm-hmm.
So it's just really interesting to think about.
Yeah, definitely. So what do you think, guys? A really good meeting, I would say. If you want to continue, let's do. But maybe a good stopping point for now. We got to figure out how to get Neil. I could probably put it together. Do you think that? I'll talk to Neil, I guess.
Yeah,
I am recording it. So, but good topics. Anything else?
I think
anyone
so. Yeah.
Want to discuss?
Yeah, I just kind of felt that I was talking too much today.
No, it was good.
No.
It was good. It was good. We'll just, it's one of the things that we're all learning here. It's kind of like this has actually got elements of Toastmasters learning how to speak in public, etc. Which Eugene, you're already great at this. So. But in this environment, it's good to which we often don't do, is bring in the other voices that might be a little bit less assertive. I think it helps. So, but we can all participate in attempting to do that. But
maybe I could say something.
There's a quiet voice.
Yeah. There's a voice of the past. I wanted to just say I enjoyed the whole conversation, and you should congratulate me because I figured out how to turn my mic off.
Oh, yay. Man, congratulations. All right.
Even an old dog can use me.
See, they can, believe me.
We're all happy now.
Yeah. It's good to hear your voice, though. I'm glad you joined us. So so we'll meet up. I'll send out the invitation for Tuesday, and we'll continue the whole thing here.
Upcoming guests, maybe shortly.
Any ideas? Any ideas on who we could potentially bring on?
Well, yeah, I would like, unless somebody else has something first.
We're still trying to get David Brown and Jacob Gable both on the show at the same time, because they're both doing those chamber experiments with the.
Yeah. Did you see the stuff from last night?
Yeah, with those clay balls. That was really cool.
Yeah, definitely.
Then,
that'd be nice. That'd be nice.
We just got to line up some time when they're both available at the same time.
That stuff got eaten away quite rapidly there, huh?
It did. It picked up like a wildfire.
Oh, yeah.
Do you mean this clay sphere? Or,
yeah, here, let's see.
Yeah, pull it up.
Yeah. Let's see.
Yeah, I saw it in my Facebook feed. Like,
if you're familiar, Eugene, with Jacob's work, where he's doing the plasma work with the sand inside a glass bottle, and it created some crater forms. Well, David Brown's doing similar things, but with like anodes inside, like a little anode inside, like either terminated quartz here, or like clay balls that he puts like a nail inside and hooks up to a wire here, and then shows how things react.
Yeah, I love that. That's just fantastic.
And it shows cratering, and it almost looks like Phobos on one of these things. It just blows right out the whole front.
And speaking about Jacob, we actually exchanged several emails a couple of months ago. He was writing to me, basically asking what do I think of his experiments. So I gave him a couple of comments on that.
All right, cool.
These just make great YouTube to begin with, and it's super interesting. And we'd like to explore, possibility of extending this exploration. Just it's kind of like the low budget. Thunderbolts has the Sapphire, but we could set these up fairly inexpensively and just check out all kinds of things. I think.
Yeah, Sapphire is really amazing. I mean, just the amount of work that they put into it, both by, practical terms like engineering and theoretical also, like when Monty said how they were evaluating the heat fluxes and so on. It's just mind-boggling amount of work.
Right.
Yeah.
Where do they have that thing?
I think it's in Toronto or somewhere.
Yeah, Sapphire is in Toronto.
Okay.
I'm not sure about that. Because Michael Claridge complained to me once how he should cross the border between the U.S. and Canada to go there. He lives in Boston, I think. So he had to travel to Toronto, and he was just like complaining when one time he accidentally like mentioned that he goes there on business, when he had to file this paper on the customs service. So, and they were like interrogating him a couple of hours. Like,
wow, right. Right.
What kind of business? Taxes and so on. So he said,
you said it was a tourist visa here. Now you're saying business. Explain yourself.
Yeah.
And Canada is particularly known for this. Yeah.
So he said that from now on, he no longer states that it's business. He just says it's a personal trip. Yeah. So yeah.
Right.
Same here, especially in Denver Airport. What are you coming to do here? Visit the beautiful mountains. Oh, okay, that's logical. There you go, sir.
Right.
Just and it's
Denver is its own conspiracy theory hole.
Oh man, that one. That one, I'm getting like a personal thing on that one, and it's like I'm curious what happened with that baggage claim system.
Oh my God, what happened with everything there?
This was L.A. Last night or night before last. But 1 second, I'll show you. You got to see the frames on this. It's pretty amazing. So this is like a really wide area shot here. Hold on. Stop. But
is the lightning striking the ocean? Or
I think so. But there was some. It made landfall for sure. But just some of the frames are just come on. I was able to get it to let's see. Come on. Okay, there we go. I can get the frames here. But they're just mind-boggling. Look at how bright that is. And you can see like. Anyway, I'm actually playing around again today with modeling some lightning. So pretty cool though, right? What else? Oh, let's see. We have this is a very interesting article that we ran across. So you just give you a quick overview of. If you ever feel like checking this out, this image particularly has been. It was a big hit. Was a big hit last Tuesday. They were talking about, particularly considering Jim's filamentary model.
But it looks so familiar. It's more or less old.
Yeah, it's an old one. Yeah, it's an old one. But just as far as let's go back. Yeah, just as far as the plasma filamentary, the spatial frequency thing. Oops, it's pretty strong there. I think if we go down in. You see these. And still the mainstream. This is all. It's all death. That's the result of an explosion, right? Another one we could explore, later on. But I'm curious as to what just off the top level, Eugene. Do you buy this? That this is just the aftermath of an explosion?
I don't think so. I mean, how is that so linear, so to speak? I mean, the explosion is just usually radial symmetry or something.
Right. But I mean, you see these, superposition. I'm sure, superposition of effects. But there's such clear to me. Just different levels of these helixes going recursively down.
There's at least 3, right?
Are you familiar with the work of Ignacio Cisneros?
No.
He has been participating in a couple of EU conferences, the Thunderbolts conferences. Okay. And I happened to visit his talk at the breakout room. I think it was in 2015. where he basically he was playing with the data from these telescopes like infrared and maybe X-ray.
Yeah, Gene mentioned him one time. I know now I know who you're talking about. By playing around with like I mean, from my level, like Photoshop filters and curves and that type of thing to bring out.
And he was comparing the images of the same parts of the sky at different times, and he was like showing how these filaments just appear out of nowhere, basically.
Right.
And it was just such a great talk of his. Like, I mean, he really knows his stuff, and he kind of is very artistic, which I also like.
Right.
And I also spoke to Michael Claridge about him, and he absolutely confirms what I say, basically.
Right.
The guy's he's just like a maverick genius.
This is a beautiful. I mean, it's the acceptance of this process is bringing those two, like the intuitive nature of what that is, along with like really good solid data. Because that's what they're doing with the Juno mission. All those really profound shots of Jupiter are enhanced, color-wise. They are.
Initially, they didn't even include any cameras on Juno, but the publicity department basically said, you have to put a camera on it.
Yeah.
Otherwise, we wouldn't have as much an impact.
Is that really true? That they did?
Yeah, I believe so. Yeah, wow. I mean, they basically only wanted to have all these, plasma magnetometer kind of instruments and so on.
Wow. But how would they reference things? I mean, that's a wild thing to think about that they would do that.
They have like a whole website for people in the general public to go through their pictures that they've taken from that and modify them, filter through them, look at them, do things to them, and then submit them back to NASA.
Mm-hmm.
So it's definitely an interactive program.
Yeah, I mean it's anyway. That is a big. There's another one that's out there. Just it's kind of the flip side of it, but you may have seen it with the. It's like deep filtering of images with on Google Images. They'll go in and they'll be like crazy, just they'll put AI, they'll put the term AI on it, but it's like pattern recognition, and then this they end up looking really psychedelic automatic mashup of things, and then they do them on GPUs, and it's wild what comes out of them, but it's got somehow for me similar aspect to it. What is our perception of things? Here's a wild way of looking at something from a reference to our looking at perception. So as a focal point, looking at perception.
Well, but that's what like all like of my work with these images has been, is like going through the images and seeing other things inside of them and then running them through filters to try to show other people what I'm seeing inside of them, like what's already present there. And it could be figures, it could be vortices, it could be all kinds of different things, but there's definitely, like when I put them up on Instagram, people are all about it. They really like them. People are doing other ones too. It's just like there's something out there that we're seeing and it's familiar. Like I love that where you're like, this is familiar. So it's like, yeah, this image is familiar. And I could see like 1,000 things happening.
Yeah. I mean, it's a fun thing to do. I mean, it is you go in and you let the thing bring up what it does too. Anyway, there's all kinds of ways of approaching this, but there's a lot of new ways to look at all this. The data that gets collected on the internet, since it's just it's just this crazy That's the right word for it, like a treasure chest of data that can be just, you know, we all have our little magnifying glasses and can look at it our own ways and find things that we never be able to have never been able to be perceived before. So anyway,
yeah, I believe that crowdsourcing is the way to go for science, basically. We've talked about this with Todd Kleckner a lot, because, you know, he's very much into citizen science kind of thing.
Right.
So we've had a podcast with him where I talked about how the internet basically have made a revolution in terms of knowledge comparable to the revolution that the printing press brought in its age. I mean, how the printing press destroyed the church monopoly on knowledge when monks were writing books by hand.
Right.
And now everyone could print his own book and spread his ideas. Now the internet also makes it possible for everyone to share their ideas outside of the realm of, you know, like sort of mainstream accepted academic science and whatnot.
Right.
And so it makes possible for us, even right now here, to connect and speak about those things, even though we aren't actually academic scientists. Right now.
Right. We actually have more, you know, we have much more latitude because we're not locked into a certain dogma. Usually as we've discussed a little bit, but usually in academic departments, you're going to be locked into a certain, although they won't say it, a certain dogmatic position. And it's really not in your best interest to explore somewhat exotic or novel, you know, pathways.
The word fixed position, like, because, like, you know what I mean? To put dogmatic on it kind of like makes people, you know what I mean? Because it can be dogmatic, it is dogmatic, but I think that fixed, because some people don't mean to put that kind of like intensity on it. That's what they understand it as being, and that it's decided it's unmovable now, so this is what it is. You know what I mean? But like, just I to say, like, to look at it as a fixed as opposed to a malleable or fluid idea.
Right.
I think that leaves it more open for everyone.
Rather than dogmatic. Yeah. But then the specialization too locks whoever it is. It locks them into that thing. I can talk about this one little facet, but if I go wider, you know, I'm out of bounds.
Yeah, and this is a problem. This is a big problem for science. And even Velikovsky actually acknowledged this. He wrote about the over-specialization of sciences as being the hindrance on the path to its basically improvement, where, you know, you can only be a specialist in super narrow field and you can only do stuff inside of it, but you take all the other results from outside of your field as facts. Basically, you don't doubt them. You just accept them.
Right.
But what if at least some of them are wrong? You know, and you produce certain facts that other people in other areas also use as facts. But what if you are wrong because some of your input was wrong, you know, from other sciences? And you cannot know that because you just accept them. You don't doubt them, you know. So this super high interdependence of various sciences plus a super high specialization of scientists is what basically enhances the possibility of error to an insane degree. Mm-hmm. That's what I would say.
So that is exactly the paradigm. The picture you just painted there, Eugene, is exactly the picture I'm trying to break and show that it can be broken and to show that we can do it. That's basically my the corner that I'm coming from with this atomic model, to show that we can do it again, and that we can do it independently, and that we can cross boundaries of these specific fields, and that we actually are able, if we use our brains, to make a judgment, if you will, on whether something is true or false in a specific field. And we can use knowledge and data from the other fields. I think we should cross those boundaries again.
Yeah, I would definitely agree. But although I even have a more, I believe at least, more broader idea that, well, I actually kind of perceive this as the main task of my life at this point, to create a tool that would be that would allow us to visualize and conceptualize the links between basically any and all of the existing theories in science, and not only science, but maybe like culture in general. So basically, maybe kind of hard to understand, like from scratch. What do you mean?
Would you like some assistance?
No, I'm
totally, I totally agree with that. Yeah.
I think it's totally resonating here.
Anyway, what I wanted to say is that, so in our culture and our science in particular, we have different ideas, different statements, basically, like the laws of nature, theorems, the results of experiments, and so on and so forth. And they all kind of form certain networks. They're like, nodes that can connect to each other and either reinforce each other or negate each other. So they might be contradictory and so on. And what is a scientific theory or paradigm or whatever is a combination of such nodes arranged in a certain way, linked together in a certain way. So, but for basically most of such theories, there can be alternative theories that would feed on the alternative statements, again, gravitational paradigm versus electric universe paradigm in cosmology, for example. So they have very different bases of their well-being, so to speak. So they draw their power from very different ideas. And what I want to create is a tool that would be able to, and by tool I mean like software or something like that, that would be able to map all those different theories and perhaps even automatically draw possible, alternative theories or something like that. So it would be like a Wikipedia or something. So it would be crowdsourced, so anyone would be able to, put their own theories inside of it and see where they have connections to other existing theories, other existing paradigms, ideas, and so on and so forth. And maybe in that way, we would be able to navigate this whole sea of cultural ideas, and in this way, maybe it would be possible to push the science forwards.
Right.
And basically, it's an instrument of creating scientific revolutions.
I'm
or something like that.
What do you think of the work that Chris Reeve is doing?
Yeah,
absolutely. I mean, I was speaking to him about this even a couple of years ago, and he's basically doing the very same.
He's doing, he's in that direction for sure.
Yeah. So we spoke a couple of times, but what he's doing, as far as I know, he is basically trying to map these controversies, as he calls it, the cards of controversies or something like that, controversy cards. So he's trying to accumulate them manually, whereas what I want to do is to create a tool for like everyone to, participate.
So,
crowdsourcing, basically.
Yeah, I'm here. So in 2012, Christopher presented on this, and he showed his end result after you've compared all these theories as kind of this tapestry. And I've dreamed of creating this site ever since, and being a career Drupal website developer, this is my life's purpose, is to help you on this.
Yeah, see? Well, we're in concert here.
Yeah, I met him on I think EU 2016.
Yeah, I got to spend some time with him on 2017.
Actually,
it was awesome.
His talk was right before mine.
Okay.
EU 2016, I believe. But anyway, we spoke a couple of times, and yeah, so pretty much he probably is one of the very few people on this planet who understands what I mean.
Right.
and
right.
I believe
I
you guys also, yeah. So because we're pretty much in the same, more or less. At least we're all on this.
See, he's got the same problem, but it's like now here's the problem with what we're up to. It's like how do you keep food on the table? You know, because it's like this is a trick. We're trying to solve it, but it's like I think it's either feast or famine. But what's involved with the, you know, to really devote yourself to something like this, you know, ideally it's full time. You know.
And it's also much, much bigger than we think, because you're competing against LinkedIn groups and Facebook groups. And so you got to create, this is a big, big website. And how do you get enough people to get started on it is the question. And, you know, once you got momentum, then you could really go with it. But and you don't get the momentum until you have the content. So
exactly. Yeah. It's a catch-22 all around.
Well, at this point, I just think that it needs to be done, and if it's not going to be done by me, somebody else will.
Yeah. But, well, I mean, this is where anyway, you know, if we can form, and this is kind of we're talking about it, but it's form a collective where there's a wide acceptance. It's not like kind of a narrow thing. And I mean, I think we're definitely the spawn of thunderbolts, and it's like kind of like. How do you get that structured? How do you let that? And I know that Ido and James have been along this path for a while. I'm kind of I'm the newbie to the scene here a bit, but there's certainly quite a bit of passion on my part. You may have noticed, but you know, so this is you know, the fodder, the raw material is there, but now how do you get it to actually start breathing and everyone like it and be happy and psyched and you know, creating new ideas and having an influence. You know, so.
Well, so far, basically, my plan is to become a PhD and then devote the rest of my life to this project.
Cool. How far away are you from that?
Well, my PhD thesis is like 2/3 complete.
Nice.
But I still have a couple of crucial things that I haven't yet done, but I hope to finish it maybe in a year or something like that.
Okay. What is the topic, Eugene?
It's about the physics of quarks. I know that maybe you don't like the idea of quarks.
No, that's not necessarily. It's a domain that I'm trying to not go into, and you know that I have a different model. Doesn't mean I'm not interested, my friend. So please go ahead.
Yeah, well, basically, there's a problem with quarks. Well, again, where quarks come from is in like 60s, people discovered several hundreds of particles called hadrons, and neutron and proton also hadrons. And namely, hadron is a particle that interacts through strong interaction. So there's 4 types of currently accepted fundamental interactions, and that is electromagnetic, gravitational, weak nuclear, and strong nuclear. So hadrons are particles that are involved in strong nuclear interaction, and people just thought, well, it couldn't be the case that all of these hundreds of particles are elementary, all of these hundreds of hadrons, so maybe we can build them from simpler particles, much fewer of those. And there came to be the quark model, which basically stated that there are only several quarks. Initially, there was only 3 of them, but now we know of at least 6 of them, or at least it is hypothesized that there are only 6 of them. So from 6 quarks, we can build all the 6 quarks. So from 6 quarks, we can build all the 6 quarks. So from 6 quarks, we can build all the 6 quarks. So from 6 quarks, we can build all the 6 quarks. So from 6 quarks, we can build all the 6 quarks. So from 6 quarks, we can build all the 6 quarks. So from 6 quarks, we can build all the 6 quarks. So from 6 quarks, we can build all the 6 quarks. So from 6 quarks, we can build all the 6 quarks. So from 6 quarks, we can build all the 6 quarks. So from 6 quarks, we can build all the 6 quarks. So from 6 quarks, we can build all the 6 quarks. So from 6 quarks, we can build all the 6 quarks. So from 6 quarks, we can build all the 6 quarks. So from 6 quarks, we can build all the 6 quarks. So from 6 quarks, we can build all the 6 quarks. So from 6 quarks, we can build all the 6 quarks. So from 6 quarks, we can build all the 6 quarks. So multitude of known hadrons, and that is like, I don't know, maybe 1,000 or something like that. And so, but the big problem with quarks is that they've never been observed in free state. That means you cannot just destroy the hadron and put the quark out of it and catch it in your detector or something like that. Right. And it came to be known as the problem of confinement of quarks. This is literally called the confinement of quarks, the inability to observe the free quark. So the quarks somehow only are observed in hadrons. So basically, you cannot see a free quark. And this is a big issue with many people. I mean, I know that Walt Thornhill, for example, dislikes the hypothesis of quarks because of that, because we don't observe quarks. So what do you think they exist?
Can I ask you, therefore, Eugene, this isn't a question that I've had some answers to, but maybe you can shed some light there. I think you can. Why do we need, or why are the quarks, the up and down quarks that make the protons, neutrons, the hadrons, if you will, why are they needed? Why are they thought of as needed or being real? Why?
Well, there are certain, for example, the ways that hadrons, transmutate, if you like, into each other, can be easily explained with the transmutation of, this is not an accepted term. I'm just, I don't know the more correct term. So the way one hadron can turn into the other one is easily explained by the way one quark can, for example, decay into other quark, as in the sense of, for example, neutron decay, where you have neutron is, I believe, one up quark and two d quarks, and if one d quark decays,
it reverses the proton and then the neutron. Yeah, that's the reverse. Yeah.
This is one sort of one of the pieces of evidence for the existence of quarks. The other one is for example, if we scatter electrons on nuclear, on the nuclei of the atoms, or on the proton, for example, or on a neutron. So if we shoot electrons into neutron or proton, we see there's a distribution of charge, which is kind of strange. But if you assign to those different areas different charges, which would correspond to different quarks. For example, in neutron, there's a piece of an area of neutron, so to speak, that has positive charge, and there's a piece of area of neutron that has negative charge, and it is supposed to be.
You know, that doesn't sound strange to me, right, Eugene?
I know that you know that stuff because.
But I'm happy that I'm really happy that you're saying this stuff, because, well, to my mind, I just made this silly remark because it confirms my thinking. To my mind, I may not even be right there, but to my mind, it does. Please continue, because I love what you're saying.
Yeah, I don't have any problems with your ideas. I mean, I believe that they might actually be correct, but again, well, it's not certain at this point.
No, and we're not there there entirely by a long shot, right? I understand that too. I just hope it's a concept that might be fruitful for a better physics model, if you will. That's my gamble, and that's my guess, and that's why I try and make this work. And I see how it works in the atomic model, so I think there's enough to it to make it work, right? Maybe better than the current model thinking, but others will be the judge of that. That will not be me.
Well, I support your endeavor, I guess. I mean, I like what you're doing, not in the sense that I agree with it, but in the sense that I like that there is an alternative theory about stuff, and it's very interesting what you do. So I mean, thumbs up for you.
Just that element makes it kind of fun for me, if you will. It's strange but true. But it is an important element, right? Definitely.
Okay, so and there are also other super secondary evidence for existence of quarks. For example, the rates of decay of mesons, like pi meson, are dependent on the quantity of quarks, and namely the quantities of colors of quarks. Now, the color is every quark.
Before you continue, what is a meson?
Meson is supposedly a pair of quark and anti-quark. So, for example, so hadrons are divided into two large groups, one of which is baryons, and it is 3 quarks, and mesons, which are the pairs of quark and anti-quark. So baryons, for example, are proton and neutron are baryons. So they have 3 quarks in them.
Realistic particles, if you will.
Well, I don't know. Well, there's just those 2 types of particles, and mesons are the pairs of quark and anti-quark. So the rates of decays of mesons depend on, at least from this standpoint of the quantum field theory, which again is a very different topic. Why it is correct, whether it is correct in the first place, and so on and so forth.
Yeah, but that wasn't the question, right? We don't need to, we don't need to go there every time. But say what your role in this is, right?
Okay, yeah, that's what I'm trying to say. So from the standpoint of quantum field theory, the quantity of quarks, or at least the colors of theirs, directly influence the rate of decay of certain mesons. For example, pi zero mesons. So the meson with the 0 electric charge, electrically neutral. But anyway, so my work is exactly related to this problem of confinement of quarks. The question why we don't observe quarks in free state, and to do that, we, and by we I mean me and my scientific supervisor, we use the super non-trivial terminology for this area. So here people working with the particle physics, they usually use only the terminology, the methods that are applied, that are used in quantum field theory and group theory and so on and so forth. But we use here the methods and terminology that is usually used in quantum information theory, and that is kind of more closer to classic regular quantum mechanics. For example, when people build theories about quantum computers, they work with quantum information theory, and we basically derive our terminology from this area. So what we consider is how the state of quark, how the information on this color state of quark evolves in time when it interacts with the fields that are quantum fields that are sort of around it, I guess.
Right.
So, right. And we treat this phenomenon of the confinement of quarks as the result of quantum decoherence of the state of quark because of its interaction with the quantum fields around it.
So, if you understand that better, that might lead to better containment. I guess that's the more practical term.
Well,
that might be the importance of it.
I actually don't know. It's an approach. So basically, what we're doing is we propose an alternative description, I guess, of the confinement phenomenon, and by doing so, we can also maybe discover some other effects that are not known to this day. So far, I haven't found such effects, to be honest.
Well, that'd be awesome, of course, during
yeah.
or
basically,
PhD, whatever, to stumble upon something great, right?
Yeah, exactly. So basically, what I have right now is I can explain in this alternative framework the phenomenon of confinement and the phenomenon of so-called confinement. So when the quark is inside hadron, it actually behaves like a free particle, but only when it's inside hadron and not when it's like torn out of hadron. Then it somehow accumulates other quarks around it and then forms another hadron. The process is called hadronization. So somehow free quarks, again, they're never observed. They always tend to come in those lumps, so to speak, of either three quarks, which is a baryon, or a quark and anti-quark pair, which is a meson. So far, I've been able to describe the confinement phase and deconfinement phase. And I believe that the most interesting part is something in between, when the quark is already kind of free, but isn't yet confined to hadron. And I'm trying to probe this area right now, but I have actually trouble finding, since I'm using, this different language altogether, I have trouble finding the corresponding, so to speak, quantities in like the usual language that, the people working in particle physics use to compare to my data,
Well, that, and you might become pretty specific here. So there's not a broad field with data, I assume, on this topic. Regardless, that may be a well-researched topic. I mean, what you're doing specifically, that at a certain point it becomes so specific, and that's your assignment, kind of, right? It's always, new research. So you always run into stuff that you cannot readily find in the field. That's what I'm saying.
Well, basically my task right now is to find some experimental data which might be translated, so to speak, into the language that I use in order to, apply my theory to the already observed processes. That's what I'm trying to do. And I have, again, certain problems with it because the way they describe the experiments in the first place use completely different formalism. So I have problems with it.
Is most of the data from like the colliders?
Exactly.
Yeah,
exactly. So LHC,
what do you mean by different language? Do you mean different modeling, different parts of quantum mechanics, or a different flavor? I'm not sure how you say that, but what do you mean by different language, or literally like English, Russian, whatever?
No. Well, as I've said, we're utilizing in our approach basically the terminology of quantum information theory, which I believe was never before applied to this area of quark physics in particular. So
it's a different branch of quantum mechanics. Is that how I can interpret it?
So usually people work with quantum information theory for example, when you're dealing with quantum optics, the current quantum computing, the entanglement and teleportation and so on and so forth, it's usually realized with photons. So it's quantum optics, what it's called. But we're dealing with a completely different types of objects here. We're working with quarks, which are, they're not photons. This is
the more massive part, if you will, right?
Yeah, and photons are kind of big in a way. They're like, if you consider that like the visible wavelengths, those are like 10 to the minus 6th or 7th of meter, whereas quarks are less than 10 to the minus 15th of meter.
Right.
So it's like
down all the whole way down again. Yeah.
Yeah.
Right.
So yeah.
In this sense, they're terribly big. Yeah, if you compare them to the nucleus, especially.
But anyway,
yeah, really, these are great. These are such great conversations.
I have no idea whether you guys can relate to it in some way.
No, it's great to learn about it and get more insight, particularly someone who's focused on it. Because it's very easy to just kind of scoff at something, and then you end up, you do it too much. I'll do it, but it's like often it's out of ignorance, So.
And to this point, I myself am not sure that quarks exist. That much I can tell.
Mm-hmm.
So I'm perfectly fine with having a parallel, different theory where there are no quarks.
Right.
And I can.
Well, it's the need for a box. The need for a box to begin with. I mean, I like the idea of kind of attacking that. We need to have a box for something,
Conversely, Eugene, I never denied the existence of smaller particles creating the protons and what we call the electrons. I never denied that, right? I always said in the modeling that I'm talking about, that's where I draw the limit. I start with the proton and electron, and those are recognized particles as well, right, in their own right. So that's what I always said. Now, you know that I disagree with quantum mechanics postulations, the fundamentals, if you will. I simply disagree with them, and I think I can at least, defend those positions, if you will. Doesn't mean I'm right, doesn't mean I'm wrong. But, so what I'm trying to say is, first of all, I loved your explanation. I thought it was very clear. I hope you get your PhD and all that. I think it's a marvelous research, And I do hope to learn something from it, not because, so I don't subscribe to the model and I try to do it different. I have my reasons there, right? But it doesn't mean you're not doing something right. It doesn't mean you're not studying a certain phenomena. It's from a certain model, which we call quantum mechanics, or a certain flavor of it. So I'm trying to be very respectful in that way always. But the only problem starts to arise when people say, nope, quantum mechanics is the only real thing, cannot go this way, cannot go that way. It's like you're confining me and putting me in a prison again. And that's different. But I love talking about stuff like this in this way,
yeah.
That's so good.
I'm not like that. I mean, the very idea of mine, the project that I was talking to you about just a couple of minutes ago is absolutely contrary to this idea that there's, the absolute truth that everyone should subscribe to. No, I'm stating it as a like my motto almost, that there are infinite number of alternative theories and we should consider the science not as a sort of a tree with a constant, trunk and only little branches coming out of it, but rather as a network where you can shift gears almost instantaneously to other, configuration of nodes rather than,
yeah. And as I always argue, I know, and I'm sorry to interrupt there. As I always argue that science is more a process to reach a certain understanding / truth than sticking to a certain truth, which becomes dogmatic then, right? So it's more the process.
I absolutely agree. Yeah, it's like a fungus growing, through the soil or something like that. So certain parts of it might die out, so certain other parts might prosper at some point, and it all depends on, local conditions, the new data, so to speak, the new elements that it takes in from the soil and so on and so forth. So yeah, and this is basically the foundation of my idea that we need this tool for science to develop further.